The first thing we have to cover is the chain rule. So I'm going to review the chain rule. So given a function f of x, and we'll say it's going to equal 4x to the fifth minus 7x raised to the ninth. Okay? So what I'm trying to show with the different colors is an outer function and an inner function. Okay? Where f is our outer function and inner function is g of x. So in this example, the parentheses raised to the exponent of the ninth is my outer function, and my inner function g of x is in purple here. Okay, so if I take the derivative, if I go from f to f prime of x, okay, using the chain rule, first I have to start off by bringing the 9 down, okay, and this becomes an 8. The inside stays the same, 4x to the fifth minus 7x, and now I need to take the derivative of what's on the inside, which becomes 20. 5 times 4, 20x to the fourth minus 7. Okay? Now, formula-wise, from here to here, this is really f prime, the derivative of the outer function. The inner function stays the same, and then I multiply by the derivative of the inner function. Okay? So that's our example. We'll come back to that. The first thing I want to do is just introduce the concept formula-wise. So if I integrate this, so I'm going to put this over here. I want to integrate f prime g of x times g prime of x dx. Okay, so what we're going to do is we're going to do U-Substitution, in which case I'm going to pick a u, and this u, I have to look for, one of these has to be the derivative of the other. Okay, so I'm going to start with the lower term, g of x. Okay, and now if I have u, I want to take the derivative of u with respect to x, and that's going to be g prime of x. Okay, and notation wise, usually what we do is we take this dx, because I'm taking the derivative of u with respect to x, and I'm going to move it over here, so it'll be u equals gx, du equals g prime x dx. Okay, now where does the substitution come in? Alright, this term is my u, which connects right there. This term, the g prime of x dx, becomes right here. Okay, so the way I rewrite this now is the integral. My outer function, notice, stays the same. I haven't substituted that out. Becomes f prime. Now I have u, g of x became u, and I'm multiplying this g prime of x dx now equals the value du. Okay, this is U-Substitution. So now what we'll do is we'll go back to this example that we had above, this f prime of x, and we're going to integrate that. Okay, and one thing I'm going to do before I start the integration, I'm going to use one of the properties of the integral, and I'm going to factor out that 9. Okay, just checking the camera. So I factor out that 9, and now I'm going to insert this function as it's shown there. So I have 4x to the fifth minus 7x raised to the 8th power multiplied by 20x to the fourth minus 7. Okay, and I'm integrating that with respect to x. Okay, so again, I've taken this exact equation here, and I've just taken my 9 out and factored it out as a constant, which we'll see later how that works well. Okay, so again, I have to pick a u, and I'm looking for one thing that looks like the derivative of the other. Okay, so 4x to the 5th, if I take the derivative of that, I'm going to get 20x to the 4th. So this is my most likely candidate for my u. Usually your u will be inside of an inner function. So whenever you look at something, here it's easy to see because I've highlighted in orange. The inner function is the parentheses raised to the outer function is the parentheses raised to the 8th power. So I'm going to pick u is equal to 4x to the 5th minus 7x. Okay, then the derivative of u becomes 20x to the 4th minus 7 dx. Okay, so now what I have to do is I have to check and see did I substitute everything out of the equation. Okay, so here's my u, which is here. My du is the 20x to the 4th minus 7 dx, which is all right here. Okay, so as I rewrite this integral, my constant 9 still stays in front of the integral, and now it becomes u raised to the 8th power. Okay, so my outer function remains. I've substituted out the stuff inside, and it becomes u raised to the 8th power. Okay, and then I'm multiplying that by du. Okay, so at this point, we've simplified it down into an easier to understand integral. And this is going to become 9 u raised to the 9th power over 9 plus c. The 9's will cancel. I substitute back in the u. Using the original u value that I had up here. And I'm going to get 4x to the 5th minus 7x raised to the 9th power. Plus c, because I have an indefinite integral. And as you see, 4x to the 5th minus 7x raised to the 9th is the original equation that I started with. So the bottom line with the substitution rule is you're undoing the chain rule. So here, if I take the derivative with the chain rule, I can undo the chain rule with substitution. Okay, so the tricky part is being able to see one of these is the derivative of the other and choosing the correct one. Okay, the next step with substitution is dealing with a definite integral. Okay, so in this example, I'm taking the integral from 0 to 1 of 4 plus 6x, the whole quantity, times e, raised to the 3x squared plus 4x, where this is all in the exponent of the e. Okay, and I'm integrating with respect to the variable x. Okay, so as I look at this problem, and this does not look like a problem that I can easily do by hand, so I want to transform that into an easier to read problem by means of substitution. Okay, so usually I want to pick my u is my g of x term, and that's going to be this term up here because this looks like the derivative of that. So if I take the derivative of 3x squared, I'm going to get 6x. Okay, so that makes sense for me to go from u to du. And usually anytime you have an e, you'll always pick whatever's in the exponent. So in this case, I'm going to choose 3x squared plus 4x. And the derivative of u, or du, becomes 6x plus 4 dx. Okay, so to check my substitution, this is my u, and the 4 plus 6x and the dx are all my du. So I can rewrite it as the integral from 0 to 1. The e remains, raised to the u du. And the integral of e to the u is just that. So I get back e to the u evaluated from 0 to 1. Okay, so now before I use the fundamental theorem of calculus and take the upper minus lower, I want to substitute my u value back in. So this is going to be e to 3x squared plus 4x. Okay, this is my original u value. I'm putting it back in. And now I'm going to evaluate this function from 0 to 1. Okay, which is going to give me e to the 3 times 1 squared plus 4 times 1 minus e to the 3 times 0 squared plus 4 times 0. Okay, this is going to give me 3 plus 4 is going to give me e to the 7th minus e to the 0. And if I simplify that in a calculator, I'm going to get 1095.63. Okay, now I'll try a couple examples without the colors. So if I'm given the indefinite integral of the natural log of x divided by x, integrate with respect to dx, I'm going to choose the natural log of x as my u, and the derivative of u is 1 over x dx. Okay, so the u value becomes my numerator, and this x over dx becomes my du. And this becomes the integral of u du, which is as simple as u squared over 2 plus c, and I substitute my u value back in as the natural log of x quantity squared over 2 plus c. Another common one that comes up will be trig functions. So if I see the sine of 4t dt, okay, I have to use the chain rule to take the derivative of that, so I have to use U-substitution to undo the chain rule. So my u value will be 4t, my du value will be 4, the derivative of u is 4 dt. Okay, so I rewrite this as sine of u du. Okay, now as I substitute things out, here's my u value, here's my dt. Okay, and the one thing that I haven't substituted out is this number 4. So the way I can get rid of that is I can divide both sides by 4. Okay, the 4's cancel on this side, and this becomes du divided by 4. Since 1 over 4 is just a constant, I can factor that out as 1/4. It becomes the sine of u du. And then I integrate the sine function, and the easy way to remember the integrals is just to remember the derivative rules. Y goes to y prime, so the derivative of y is y prime, the derivative of sine is cosine, the derivative of cosine is negative sine. Okay? Notice this top column are both positives, and this bottom column are opposite signs. Okay, so in this case, if I want to integrate, I'm going to go in the reverse direction. I'm going this way. So I have to integrate the sine function, and now here it's negative and here it's positive. So I'm going to integrate a positive sine, which means my answer is going to be a negative cosine of u plus c multiplied by 1/4. And now the last step is I have to substitute back in my u value. So this is going to be negative 1/4 cosine, and my original u value 4t.